Good morning. My name is Fernández, and I'm in charge for sales. I'm Claudio. I'm in infrastructure SCSI, and I'm also in charge of CPDS and cloud issues. When we were thinking about this talk, because it's going to be more of a workshop than a talk, we had to take into consideration a series of circumstances which I think are important, which is we had to understand what we mean by a cloud. I'll give you an example. When Claudia said to me, "What's a cloud for you?" I gave a series of definitions. When he explained to me that actually cloud is a business model from which we're going to build a series of solutions, then it would seem as simple as you'd seen it in the beginning. But let's just have a look now. When we talk about cloud, what do we mean? Cloud is an evolution of a traditional business, which is basically a network of computers. And it's a business that's based on sharing resources, quite literally. Some, like sales, directly talk about it as a private network, but actually it's not, or it could be. Cloud is a business model which is still being developed and which is growing very quickly. And we shouldn't forget all the concerns relating to security and our business that it has. We've got an example here, these two important people who are a bit outdated now, who thought that the market had finished almost 100 years ago. And yet, as things stand today, we haven't even reached half the potential that this world can reach. The world is increasingly interconnected. There are more and more devices every day that are connected to the same suppliers, and we don't even know where they are. What are we going to talk about today? We're going to talk about IT, traditional IT, cloud computing, and security audits and hardening in cloud systems. We all know what traditional IT is, which is basically what any company or a person has. For example, at my house, I've got all different pieces of devices, and depending on the kind of infrastructure that I need, I can invest more or less. Of course, these kind of equipment sometimes aren't enough. We have more requirements, and that's when cloud computing comes into play. And what cloud computing does for you is, according to your service needs, you can actually add space instead of investing in a new piece of hardware. And these kinds of solutions also lead to a series of problems, which is what we're going to try to talk to you about in today's talk. Let's first look at what we can expect when we work with cloud systems, how we can implement them correctly, and how should we start investing in cloud computing or not. As things stand today, basically everything is connected, from our desktops, our servers, our mobile devices, even have networks that are directly deployed in cloud. We've got, for example, we could have our whole business network on a cloud. We also have databases and other services that are in a more industrial level when we talk about cloud computing. Let's concentrate today more on the difference between traditional IT and cloud computing. In traditional IT, what you do is like having a meeting. You say which equipment you want, who you're going to buy it from, how you're going to buy it, and who's going to fund it. What cloud does is it allows you to change this business model, and you end up contracting all the services that you in the past used to plan with a lot of investment in time and a bit delayed, as if it was like a mobile telephone service. And we pay per use rather than paying for maintaining hardware, etc. One of the things that you need to take into account when you talk about traditional IT is that you're going to need far more staff. You're going to need systems administrators, operators, and places to have this installed, these things, these devices installed. And at the same time, we need to remember that they can be used by just one client. But when you talk about cloud computing, these problems disappear to a point. You are going to need specialists. Of course, you're always going to need specialists, but if I wanted more processing ability in the past, I had to buy more pieces of equipment. I don't do that anymore. I just say to the supplier, can you extend my... And so I can take less time, the cost will be lower. And if everything is all right, and now nets are multi-tenant, it's going to be accessible anywhere. And of course, that's always something that's important. Cloud computing can be defined as a model to make convenient access easier for people that demand a set of computational sources. Cloud computing, according to its definition, has to meet this definition that's up on the screen now. Maybe Hotmail was the first to meet this definition. The idea of a cloud is that you've got direct connection to the supplier. You can sign off, you can make it bigger without even having to send an email to your supplier. Having said that, nobody knows the Hotmail telephone number. It's no longer a traditional supplier. What they do is they offer you a platform, a server where you connect, you carry out what you want to do, and then you carry on with your daily life. What's interesting about this, and I don't know the Hotmail's telephone number, but what they're doing is imposing you a series of conditions that you have to accept and take on board. And if you've got a problem, there's only usually one channel for solving the problems, which is usually the solution that always works. It doesn't depend on anybody, and that makes it more accessible as well. Let's look at the cloud model that promotes availability. When I went to Hotmail for the first time, what I was surprised is that you could connect from virtually anywhere. I said from virtually anywhere because there's always exceptions. This discovery is something that you can't do with traditional IT. There are 5 basic characteristics and 3 service models and 4 deployment models that we're going to look at now. Self-service on demand. This is easy to understand. The more I need, I just take more space. If I lack storage space, so I just ask for more space and I'll have to pay for it. My free email service has some limitations attached to it, but I want more, that sort of thing. We need to consider elasticity as well. The cloud theory is that it's infinite. We can ask for as many resources as we want. We can link up to different cloud types or different suppliers. Or we can have community clouds. And one of the advantages is that it's easy to access from the network. And it's a measured service. And it's a measured service. We can know how much we're using RAM, disk space, bandwidth, everything that you can want to know, and some things that you probably don't want to know. All of these platforms give you infinite transporting systems that allow you to measure and contract basically what you need. And what's more, the great cloud advantage is that it's easy to access from anywhere. So the paradigm shift here is enormous because in the past, we got a server and we opened ports and accesses according to our needs. And now it's a service that's offered and we close ports as problems arrive. When you use these kind of services, normally everything is open and then you close afterwards as you don't need it. You just close things behind you. This is a good practice for the simple reason that it forces me to check each one of the steps that I have to do to try to solve things. Because otherwise, you get a bit lazy about doing things and you can leave things open. One important thing of this made-to-measure self-service is that you can contract according to minute, and the terms of use change every minute. Every time you accept a service agreement, and this we see quite frequently with Saas services such as Google Maps and Google Activities, where you sign up and you've accepted things by default. This is quite a common practice, and any of you you see any sort of service that you have, Facebook, if you put it on a cloud, you put it at the moment they talk about new conditions, you need to look at and review all the different privacy options. Okay, the resource sets. These resource sets always there to serve several users at the same time. Even if it's a corporate cloud, it's the same because it's a multi-tenant with several physical resources and virtual resources that are allocated and reallocated according to the requirements of the consumer. So multi-tenants are for internal consumers, not external ones. Let's look at software as a service now. Let's look first at SaaS, software as a service, which is obviously one of the typical things that we'll be using. One of these key is Hotmail or Gmail. Thing is with this is that we're going to have a very flexible solution, but that means that we don't have any control over it. Does anybody here have some control over the logs that Hotmail, Yahoo, or Google Mail can generate? No, that's outside of control. Of course, the solution is in the hands of the person that serves us, but as a customer, we don't have that control, especially in software as a service, SaaS. We have to remember that the person in charge of the platform is always the supplier. We're just responsible for access. It's very important from a legal viewpoint and a forensic viewpoint. We need to know that we can't get much out of a supplier. If there's been a security problem, you won't find out what's happening until the supplier actually tells you. What's interesting about this, as Claudio said, is that however much we ask from the supplier, very infrequently they're going to tell us what we want to know. They always say, oh no, we can't tell you about this because of confidentiality issues. They won't give you anything, even if you take them to court. If you get a bit arrogant, they won't reply. Platform as a service. If there's a developer in the room, this will be your starting point for all the daily work that you do when you create a new service or platform. The difference between PaaS and SaaS is that the system logs are a bit more profound, and in the platform you can see how many resources you're using. Normally, platform as a service is used by development teams to create platforms such as Facebook, Gmail, etc. Before putting them into production, you do all the tests that you need and see what capacities you need to contract with a new supplier. The great advantage of this is that a developer is going to contract for a limited amount of time the resources until they develop their app. This means that there today are as many platforms as apps that we've sort of lost sight of them because of the fact that many PaaS platforms are free, such as Google Developer. And this is to encourage people to use them service. And then we need to really look at the service conditions. This is very important when you look at the platform that you're going to work in. Otherwise, you can get some very unpleasant or pleasant surprises. So you need to read the terms and conditions before you get involved. And the thing that I like and that perhaps we use most is IaaS, Infrastructure as a Service. Here we can contract services such as RAM, CPUs, virtual CPUs. Normally, IaaS are virtual machines, virtual computers. They're an infinite number of other services, but actually, really, they're just infrastructure. Of course, it has to be shared infrastructure. It's not, you can't just have a dedicated server. And here I can see something that I've been struck by. You said that they have to be shared. What does that mean? Well, it means that in the same disk we're all together. You can have the same CPU or the same RAM set or network sources. So that means I have to share my resources with somebody who I don't know. What happens if my machines are shared with somebody who I don't know them? What happens if there's an incident? How do I get an image of my memory or the disk? The cornerstone of cloud computing is virtualization. Virtualization allows us to do what are called normally snapshots. It's an exact copy of the machine's state at that time, which in many platforms you can include a snapshot of the RAM. You can see what you've got in your RAM in a snapshot. But what about other people accessing my snapshot? Well, it depends what you have to do, the routes that you follow to get the snapshot. I'm going to write this down. I'm just interested in seeing how accessible a snapshot is at a given moment in time. So it would be looking at a snapshot of a virtual machine. You may find you've got other problems. You may have a very young cloud supplier, provider, who've got resources that are limited, but because they don't know or because of malpractice, they directly just have one network channel to manage, to store internet. So for example, if I've got access to this only channel, this single channel, then everybody can access mine and everybody else's. Well, yes, you can see all the hard disks of everybody else. This isn't normally done. For example, maybe I want to get into their area. If you don't have the credentials, you can't access people's machines. You can go and look at their drive, but it might be worse if there's a management change. You can see the access. This is never done. Well, they shouldn't do this. Okay, I'm a bit more relaxed now. Let's now look at the different cloud types that are out there, just to understand what we're talking about. We need to explain a little bit about how these clouds work. What's a private cloud? And I know that this means it's a private cloud for me that I use with my people. It can be used, for example, by a company that has their own cloud. And in these kind of private clouds, it may well be that you're inside the company and the administrators outside, or vice versa, and all different possibilities and permutations. Yes, that's right. These clouds, private clouds, could even be off premises in a country we don't even know where they are. I'm saying this because I found this is interesting. The fact that you use cloud computing services, sometimes we forget to ask where they are. And these kinds of things, you need to remember that if you store sensitive data outside Spain, these need to meet a series of requirements. For example, they need to abide by the Data Protection Act and a whole series of other laws which either I read quite carefully and make sure that they're abided by, or I don't store my data there. Let's just assume that I've got a cloud in Thailand. I bet they don't abide by the law. I mean, I wouldn't store my data there. So this is something that we need to be very careful with. The problem is that if I ask somebody who's storing my data offsite, and I say to them, are you meeting the legislation? Do you abide by the legislation? They say, oh, yes, I abide by all the legislation. But you need to be consistent when you do these sort of things, because the people that are really in charge of all this is us. The buck stops with us, not the provider. They have their own rules. And another kind of cloud is the community cloud. A community cloud is like a set of clouds. For example, Yahoo, Hotmail, and Bing, for example, to share searches. So they've created a community cloud to do certain kinds of searches. Yes, they're currently developing clouds between different corporations. For example, if you don't trust the way you access your personal data, you have to actually have this shared clouds. And the one that we all use every day, which is in Amazon or any other sort of normal cloud, is the public cloud. The infrastructure side of the public cloud, whether it be Saas or PaaS, is available for the general public, for industry in general. Some countries limit it, such as China, but outside that, everybody can access it from wherever they happen to be, and we can all contract it whenever we're interested in. These are the kinds of clouds that we use when we use Dropbox, for example, any sort of service, so as to be able to access this service. So it's open to everybody. Even with a mobile phone, you're continually using this cloud without even realizing it, just because of the data that Google or Apple stores in the cloud. And this is interesting because although we're going back to the same conditions, nobody can guarantee that where I store these data. I'd like to say something about this, which is quite interesting. Normally, these kinds of data are encrypted. But it wasn't so long ago when there was a security problem with Dropbox where users had actually rubbed out these files and they suddenly popped up again, just sort of like magically. So how do I know that those data that I've wiped out aren't going to pop up again? It's not just a matter of doing away with all the data, but the visible data, but there's all these system snapshots. And we can't trust that they'll disappear. These large companies, such as Dropbox, don't store the typical shared files that we have, but different JPG files in a numbered file, and they keep all of this in database that they store. If they've got a problem, what they're going to restore is that database. But when you remove a file, you don't remove the file per se, but you remove the entry into the database. Every so often they do purge and get rid of it. But if you've had a problem, or if I knew somebody's rubbed it out, you can go back to the database and get all the archives that are available. This makes me ask myself a whole series of things. You know, are you trying to say to me that it's impossible for them to see the content of what they've got? No, they can see it. Of course they can. If I say to them, well, I want to see the content of all these archives, will they give it to me? No, they won't. Why, if it's mine? Because it's actually not yours. I don't understand. What do you mean it's not mine? Normally it's yours, yes. But you have to prove that they've got it. But if I've uploaded it to the cloud, how do you know that they've got it? This is one of the things that we're never going to know. I can be very sure about what's out there. And this leads us on to something even worse, which is data loss. You probably signed the terms and conditions, and I know it sounds like I'm being paranoid, but this could happen. Another cloud is Governmental Cloud. You can actually, if you go to an AWS, you can actually try to get this. It's like a data center. In the US, there was another one in China, but a couple of days ago, the Chinese government brought it down. Actually, it would seem somebody bought it. We don't know how it's been paid for. But these are other matters. In the government cloud, which a couple of CPDs now in the US, only certain organizations can contract AWS services. I would try to get into one of those places. Of course I would. When we talk about governmental clouds, we're talking about the fact that they'll be far more strict with their controls than others. And I was going to say something stupid. I was going to say they'll never let the clouds without the security. But if you realize that they've just found several gigas of ultra secret information, I'm not so sure about that. I know there's been a CIA leak recently of several tools. But anyway, these kinds of governmental clouds have also changed the paradigm in the way in which governments control and contract these services. There's another kind of cloud as well, which is the hybrid cloud, which is the one I really like. And there's another cloud called a secret cloud in intelligence services. Amazon also offers a service called the secret cloud. I think you can see it in some of the Amazon pages. They refer to this cloud, but there's no official documents about it. So actually, it doesn't actually officially exist. We just think it exists. Let's have a look now at the hybrid cloud, which is a mix, of course, of public and private clouds. It's usually used for privately until it's been tested, and then it becomes public. That's what a hybrid cloud is. Another classic case of hybrid clouds are those blocks, for example, of the stock exchange, where during the day they have their website and they have certain customer information, and at night they just upload a whole series of operations so they can be calculated, the ones that have been carried out during the day. It can also be used if we've got a dedicated server. It doesn't have to be in our offices. Suppose we're a newspaper, such as the Voz de Galicia newspaper. And it may happen that we've published an article, but our infrastructure doesn't allow us to send that information to all our readers. So what we do is, with a certain password, we can spread this load of this news so that everybody can get it, everybody can access it. Of the previous definitions that we've spoken about, you've now got an idea of what a NIST document is. But let's now look more closely at the cloud platforms that are available.
In cloud platforms and virtualization, we have many more than those that you see here. Maybe these are the most representative platforms, each with its own features. We can speak about VMware, the most popular, Microsoft Azure, that is becoming more popular amongst customers. Amazon, it's the platform that we all know and use for many reasons. Red Hat with its own cloud and virtualization platforms, especially OpenStack's over Red Hat. It's the most usable infrastructure. And the newcomer is Docker. It's an evolution of the classic cages. We have Citrix Xen server for desktop virtualization and the Oracle Cloud. As for virtualization technologies, it's useful to know the details. All of them have specific capacities, capabilities that are different. VMware is not the only one, but it was the only one to have high availability. So machines could be transferred to another machine, and there was a zero failure tolerance without even losing a pin. So that's important, especially for critical environments. It's used in bank environments because of fraud. All communications are controlled and stable. Lost PIN is a catastrophe in bank services. And some of these technologies are free, some others are not, and others, for various reasons, we are forced to use. Some of these platforms have entered in a specific way. Oracle, when we take a database, if we mount it on VMware and this machine is moving in, it's hot moving, we have to pay 2 licenses for that database. But if it is virtualized with the Oracle system, even if we change country, we only pay 1 license. These are details that are interesting to know, especially when you work in big companies. What I really like in cloud computing is democracy, is IP democratization, and IT democratization. Anybody can have access to a set of resources and to new technologies that only big companies could use in the past. Anybody today can have his or her small parcel of database or advanced applications. Let's see how capacity versus demand works. This graph is simple indeed. How I'm going to proceed according to this in the traditional infrastructures, or if I use a cloud infrastructure. What's the difference? When I use a traditional infrastructure, for each growth need, I have to invest more. This type of investment is good for me if the needs are always the same. What happens if needs evolve? I have to invest much more in more machines, in more equipment, more technicians, and more specialists. What happens if needs decrease? I have to maintain my machines. I can't really just sell them. Well, technicians, well, unfortunately, they disappear. And when I use a cloud technology, if I need more infrastructures, I say, give me more, and that's it. If I need less, put me less. And that's okay. So little by little, this is changing, especially at world level. We are saying, in fact, within Google search, simple one, instead of using Gartner indexes, with a simple Google search, if we look for cloud server, we obtain more than 210 million references in Google. If we look for dedicated server, the term in English, on 11 million results. So we are doing search with terms in English. In Spanish, the results are a little bit worse. In Spanish, it's the servidor dedicado in the Latin market. Nobody says servidor cloud. Well, it's just terms. The cloud has come later to Spain and to this type of markets. So We know more about trappies coming from providers. One of the biggest concern of the cloud economy is overcommit is selling more resources than the ones you have available. We won't mention the names, but during a course that we had with cloud, the provider said that he overcommit from 10 to 1 regarding the CPU. That's okay because we have a lot to offer. But this was a provider for IP voice, and we said, well, sometimes the customers complain 10 to 1 in voice IP is a little too much. Let's go back to cloud services, especially the part I prefer, the services that are not free. What is the cost of a cloud service? Depends. My Hotmail, my Gmail, my Facebook account, my Twitter account, my Instagram account, my ProtonMail account. Well, not that one. We don't pay. We don't pay any money. People say that once a product is free of charge, well, you are the product, of course. So what we do in privacy has a cost. People are not aware of privacy. People say, I have nothing to hide. And I said to them, you don't have anything to hide, but when you go to the toilet, you close the door. That's something to hide. And it's that simple. We are able to sacrifice a lot out of our lives because we don't give it a real value. But it has value. The great advantage of cloud computing and this type of infrastructures is the orchestration. These are panels where we can program all the needs per hour or according to the number of customers. We can enlarge in a very elastic way all the resources or reduce them. I say, I only have this to pay, then I can go back to the free program, but I'm going to lose customers, so I prefer to pay. The great advantage of cloud computing and in the great adoption level comes because it helps us to save money. We pay more at the end of the day, but we pay more as the giga price per RAM, price per giga, price per CPU, but we don't pay for the physical infrastructure. So we are in a better position because we exchange from hardware budget to operational budget, and it gives more value to our business. Precisely, that's the difference, biggest difference between cloud and traditional systems. In the traditional systems, I have the equipment. So if I need more, I have to invest a lot of more money in hardware. But in cloud computing, I will have many more possibilities to use this remotely with more people, so it's more interesting. And this allows us to play with our budgets. With our mobile telephone bill, we can add 1 more giga for data, for instance, and that's the only thing we need to do. The most important thing here, according to Vilfredo Pareto, is the 80-20 rule. Turnaround expenditure in hardware and the investment to keep it up and to maintain it. And now we are spending more in operations. In the past, we had an IT person fixing the printer, fixing the desktops, and sometimes they had to repair other machines in the company. Now this personnel is changed. These people are dealing with our data security, and these people are giving us more value, but they're not repairing printers anymore. And so instead of a fixed investment in our infrastructure, we have a recurrent expenditure. So once we can't maintain it because it doesn't work, we decide to pay less. We decide to have less number of salesmen because the work doesn't work, because they're not selling, so then we need less people. In cloud and services, it's like a machine where you buy soda. You pay every time you need a bottle. So what type of infrastructures will being included in some services to manage their services. This one, Netflix. What about Netflix? Is this traditional? Well, is this traditional IT? I can't imagine what this company has. Netflix, more particularly, is the giant for the cloud consumers. It's a giant company. They have no single physical servers. Everything is hired to third parties. In the data centers, they send network equipment. They only install network equipment. Once the customers go down, or well, there's a part of the services that is cancelled. But they just deal with functionality. Netflix is the big revolution in cloud computing, not just as a provider, but as a consumer. And it's a provider for Saas, especially so that we can sell our products and services. And they have revolutionized the security market, the BitHub, their applicatives to check all the Amazon instances. That's incredible, and this is very good. Let's concentrate on what we have. If I'm not wrong, you said that in this graph, if I come from down to top, you have more and more visibility from above. So if you are a consumer of IaaS infrastructure, you can see the layer in PaaS, and you can see what is the SaaS platform, the software that end users use. So you can see it from down beneath. Is that true? What it means that if you have the PaaS platform, if behind it there's a SaaS, they will have access to my data. No problem with that? No problem. If you have the infrastructures, have the access to anything on top of them? Is there a limitation? Can we protect ourselves? Well, it depends. The technician using it. A privilege escalation brings you from a SaaS to a PaaS platform, but nobody does that. No, it shouldn't be done. Well, I take note. I'll see if it's true. I suppose I can take a snapshot of one of the virtual machines that we have around us, and I want to know if I can extract something from that. Let's test it.
Dentro de Saas,
In Saas, what are these services? Well, software as a service. I have lots of services. Facebook, Amazon, Google, anything that we use every day. And we're not able to leave it. In Saas, we can even talk about WhatsApp. In this platform as a service for developers, this is great. Yesterday in the room, can you recognize anything that is not canonical? We have a developer in the room. Thank you. A great advantage if we want to create our next super application, and if we don't, we have the necessary resources, we have no funding, we have no investors, and we know that our application will work, but we need a lot of resources in a limited time to test this functionality. We have no money for drives, for RAM, memory, or for a network. For a DOS, we can go back to the words of a great Fry, and we need to buy more resources. Shut up and scale my app. Within those, we have the infrastructure as a service, the typical provider, who and where, that's important. There are changes in our legislation. We want to know in which country and which region we want to operate. That's important, this type of services. According to the type of data, you have to control it. Especially with the new data protection regulations, the person is you. At penal level, you are responsible. You have to be careful with that. You can be the person responsible for that. The great difference between virtualization and this, and that's in cloud computing, it's not only there is a hypervisors of calculation and computation, the most technical part of these data centers. Within a single machine, we can have an infinity of operative systems and individual machines. You can have your operative systems. We mount a server, we mount an operating system, and then now we have an intermediate layer with hypervision with all the operating systems, resources, plus our applications. We can create virtual applications that would compound a set of virtual machines serving a purpose. It's important to know this because in the past, we lost the control of an application and we became a server. Here we can lose the control of a virtual container and we lose all the services behind. One of the most important parts of cloud infrastructures is storage. There's a full branch in data centers. There are specialists in storage, providing the necessary space. The brands that we show here are the most popular. We're not paid for that. That's a pity. And the types of storage, well, they're different. We need to know why we use these types. The object storage, everything is put into a database, and each object in particular in another file in one or another hypervisor. The most common is BlueSRF, Ceph, if you know it. Then we have the storage by files. We've always used that, NVS. But we have another one. It's block storage. We have a critical application, okay? And it needs a dedicated resource. We use a block for storage. The RAID 10, well, you would use a fourth of this RAID 10 for us. We'll subdivide the drives for a block for ourselves. It's just for applications that require a lot of space in disks in database. We can have storages or in devices in different countries. In blocks. Well, not for the others. So I cannot ask you for you. I don't have any legal responsibility if I extract data. Well, it depends on your tools. But the provider will never collaborate with you. Today, we've tried to ask FTP logs from hosting providers, and it was impossible. We can't show you. In the GitHub that we're going to open next week for these tools, and this presentation will be there, we'll give you a censored email with conversations with providers saying, what is the color of an orange? That's a question, typical question for a supplier. And the engine for steam propelling, so you ask for a log and they just answer bullshit. Do you want more services from us? Of course, you've seen that in all type of services. As Claudia said, there's zero collaboration with providers. And I suppose it's their business because they need to protect their intimacy and the data integrity of their customers. And there's a multiple usage of that. And they're not going to allow me to access a log that comes with many other things at the same time. So don't wait for that data guarantee because you're not going to have any reply. The great cloud revolution is brought by the SDN networks. If you spoke about YASIC and cryptocurrency, this is used for cryptocurrency and for hash generation. With the network virtualization, it works fine. These are microchips that are designed for a specific purpose. From cryptocurrency, they go back to network virtualization. It's a fantastic integration for ASIC in operation. Instead of having the core with 30 fibers, we have a virtual instance with the NS applicative, and we needed a specialized equipment. Now it's simple. If I need to make an investigation, it's easier to duplicate labs than have them physically with me. What's interesting in the SDN networks, when we do an IP tracing, we get to the data center. We can go there. We know in which data center we are because we are trace routing. And we get to X number of suppliers. We know that we've gone through the X node, the X hub. And we know it's in Spain. We know in Amazon US. We know where we are. In this type of networks, you have the bidding where traffic is exchanged in a transparent way between suppliers. But in fact, the package is not here. It's in Germany in milliseconds. It's not here. So this tracing system is a bit complex, not only complex. In many investigations that we can make when tracing up a communication, this means it's full of errors. It's interesting. The load balancing is fundamental. We have many products to do this, load balancers. Maybe you don't want to hear that, but our internet providers use load balancers to know about our routers information exchange. It's kind of a single machine. A single machine cannot store all those data and to have all this traffic. They distribute it between the various machines. And here, the most important are the database as service. The Oracle license is very expensive. Other technologies are quite expensive. So what do? We hire a portion of a database to a provider for a monthly payment, which is not very expensive. So avoid the great investment. So the question is to cloud or not to cloud. I take my infrastructure to the cloud or not. How can I assess that? It's if your infrastructure is your business core, don't put it into the cloud. Your core cannot go to a cloud that is shared with many people. You have to assess the risks that are associated. To change your infrastructure or put it into the hands of other people, who's others? Because the cloud model is a collaborative economic system. So we think we have a product with a provider, but the provider has not all the resources. So it's being shared with, the resources are shared with Amazon or with another company. So what I need to know is that if I have to use cloud computing, I need a way to administrate what's happening in my cloud. Yes, you need a well-defined plan for risks, compliance, security, and hardware. You need to define these plans. You need a lot of meetings, many questions to your provider, and very uncomfortable questions. So let's imagine I take my infrastructure to the cloud. What do I need? It's an outsourced service, external service that you need to relocate your personnel. It doesn't mean to put them on the dole, but this personnel have about all the knowledge about your physical infrastructures, but they know what happens to a piece of data from A to Z. Your personnel know everything about your infrastructure, so you have to relocate those people. This person knows all the route that data follow. So you have to put your business meetings, and you have to have new ARP tool or workflows that are more adapted to the new infrastructure you're going to have. So reallocate resources. So I take my infrastructure to the cloud, and it's true that I have to replace and relocate my people. And I don't know who. And maybe they're going to have an influence on my infrastructure. You need training and more training. I agree. Now we get to your favorite part. So think, now we know what the cloud is, how we can move around, what are the risks that we have imagined. How can we now avoid those risks? So what are the risks that we're going to be faced with? First, the loss of governance. It's clear. The provider is going to control what you do. I can't control anything. And that's a loss of governance, and it's a risk. How can I solve this risk? Well, I have to trust him. I have to trust the contracts that I sign with a provider. Okay, Let's imagine this is a case of a provider I'm not going to name. They sold IP voice services, and they closed their service and everything, lost the land telephone number, so disappearance of telephone numbers. Another risk, and this is especially linked to the price. It's not the same to pay for a service for another service. If I have to migrate the content on the cloud to another place, what are the services that are offered to me? If it was like telephones, do I have the possibility to leave you? Because I have all the data. Can I leave my provider at any moment in time? I need freedom, and you have to be careful with those services. Yes, there's a risk. There are two questions there. What is the technology that we use? The vendor log. We are forced to use the vendor with the same technology, or can we migrate and choose another vendor with another technology? And the provider's honesty. But all providers are honest. If I say to Amazon, I want to take all the services to another place, yes, of course, you can do it. Well, Amazon has a specific policy. It's quite serious. It's quite okay and honest. That's normal? That's usual? No, it's not. Okay, so careful with that. Another risk. You can't be isolated when using the shared resources. During our talk, we said that shared resources are going to be violated on many occasions. It's not the same to have a provider or a supplier ensuring that than to have anybody there. It's like having all the shared resources and anybody can have access to that. It's one of the risks. Yes, there was specific failure in Amazon. There was a fault. From one instance, you could have access to hypervisors. You could have an Amazon virtual machine with faults and errors. The buffer overflow allowed you to have access to all the machines that were under the same hypervisor at the same time. There was a programming problem there, and it could be a catastrophe. You can have access to anything, and that's dangerous. Another risk is compliance. The provider not only has to demonstrate to me that he has the necessary resources, has to allow me to make an audit. Tell me what you want, but I want to check that it's true. Why? Because when I have to comply by the law, to abide by the law here, I'm responsible for that. So this is not respected in many cases. It's one of the highest risks that I can face. That's interesting. More risks. And I suppose that you know that you can be mining Bitcoins without knowing it. You don't know it? The JavaScript systems are continuously mining Bitcoins. Any management interface that is accessible through the internet can be vulnerable. Everything is vulnerable. So, plus, I have the browsers all around me for my customers, and they are all vulnerable. I find one of these vulnerabilities, and the FBI discovered people in a Thorpe network because there was a Firefox vulnerability in the Tor system. So maybe I don't need to update the systems, and thanks to that, I'm going to have a vulnerability that through my computer and through my web systems, people are going to access to all my company's resources. That's not very nice, is it? We need to adapt to the laws, to abide by the laws and regulations. And I insist, you have to ask your provider the real proof that the provider is abiding by the law. And to be sure that data are destroyed when they should. They have to guarantee that they're going to destroy my data when needed. Otherwise, it's a risk. For example, in a cloud company, they just remove the backups and they give them the drives to another person with confidential data in the hard drives. Or a person goes to the photocopier in the company, they get the hard drive out of the photocopier and they go away with it. You know what it contains? Lots of data. I have evidence of bank operations in banks here, and they were contained in those photocopier hard drives. They should have been destroyed. If you see an old machine, you get the manual from the machine or for the photocopier, the printer. So you see all the photocopies that have been made at the copiers. Normally, they keep a little log, a small snapshot of the photocopy that has been done. You can find anything. Autopsy is a forensic software that allows you to study evidence, and it's very well used. You can work with the snapshots of virtual machines. It's very simple. Not only is that the only option for that, we'll see more details about this.
What's more, another major risk is for the technicians or administrators or people that are directly handling the data. And I don't mean my people, I mean the company that's stored my data. Who am I to know whether somebody's fed up that works for that company because they've reduced their wages and they do something with my data or some other company's data? This is one of the risks that you need to consider. What we're clear on is that you need to consider all these risks. You need to have them all in your head. And whether we like it or not, when we're in a cloud, we're going to be exposed to a series of situations and circumstances that we're not going to be able to do anything about. People are going to be able to access from outside, and they're going to try to access as well from inside. What about strengthening cloud systems? First of all, you need to have legal adherence, especially if we encrypt. We've got a password manager or the internal company management where we've got half of the password and the others have got the other half. We always need to meet legal requirements. We need to be sure that we're compliant, whether that's with automatic tools or different technologies, or so we need to be clear that our data are kept under the best conditions possible, that there's a way of data destruction, that good security policies have been defined, that they're used in separate environments for trials, for production. And we need to check all the data environments. We've tried, as a team, to get these kind of tools. They're not too difficult to generate, where we've brought together a whole series of tools for cloud authority and different environments from a technical viewpoint and from a compliance viewpoint. Let's just have a look at how they work. So that's the theory. I know it's a pain to listen to this, but it's necessary for you to understand the world that we're moving in. Let's now work on the practical side of things. And the first practical side of things I want to propose to you is because I want you to understand that normally a technician with a certain amount of knowledge doesn't necessarily have to follow 100% of the rules all the time. And normally they can skip some of the limitations imposed by systems, however famous they may be. Let's have a look at how that's done. I'm going to give you an example with a tool that you probably all heard of. This tool, Excel. You know Excel? This is an interesting tool because you can add data, but I think somebody's actually invaded my Excel sheet. So I find this page, I know this is a bit of a cliche, but I want you to see how it works. Do you know that the majority of these files are actually like a zip container? Did you know that? So let's have a look at this. Worksheet. Here I've got a sheet that maybe I want to edit. What I'm going to try to do is to see what happens here. Let's look at the end of it. What I'm trying to find is the kind of password that we are using to try to violate this. Obviously, on a spreadsheet, you can try this at home. And I can see it's got SHA 512. So anything that I want to try to touch here is going to be a bit difficult. Here, there's some kind of protection. So I'm going to take this. My colleague forgot to install this. For demo purposes, I'm going to remove it just in case. But I'm going to save this as well. This is what any normal person would do with an Excel spreadsheet. That means that however much protection I've got, it doesn't matter. I'm going to able to get around those protections because nobody has to be honest. What I've just done this with is just a normal Office program. I don't know if you know these kind of techniques to avoid having to use a password, but I've just done it. So what you've just seen is one of the ways that we can check to see how I can violate data in an external virtual machine. We were talking about malpractices earlier. We're talking about just one cable or one channel to get to everything. What this means is it throws up very basic problems, meaning that somebody can just save this, or just because we're bad, we don't have any certificate, we just have the data, flat data. What does that mean? We can get to where all the disks are stored, and we're not going to need a brute force to deal with the machine. We're just going to access the hard drives, the machine's hard drives. Let's just have a look at something before we do that. I said to you that I was going to save something. I want to see where I've saved it, because I've got an access to a snapshot. In this case, it's a virtual machine, and it's a Linux tank. You can just access whatever you want. It's a bit like a bitnave. What's interesting is that many people use it, and if we did any internet searches, you'd probably find all kinds of these kinds of characteristics. So making use of this, let's just have a look now at its origin. What can I do with this? Well, we're one of the most complicated tools to use that there are. You remember that I said that everything is done on snapshot. That's what a snapshot looks like. It doesn't matter if it's in Linux, Windows, or whatever. What do? I go and see if there's any sensitive information here. Maybe there is. You can do this at home, on your own systems, or outside systems. And I'm going to see if I've got any access to anything interesting here. Let's see what happens. it's a big compressed file. It doesn't matter if it's got 1 giga or 30 gigas in the file. If you want to do any forensic investigation with this, it could also be useful, because I can see what's inside a file of a virtual machine or a snapshot. That's the same with Linux, with Windows, it doesn't matter. So what we're saying is here that in a Linux machine, we have different levels of permits within files. And if we get to hard disks of these machines, then we can avoid all those files. We can change whatever we want without any kind of permit at all. This is the content of a disk unit in Windows. I imagine you all know how this works. You can see the number of users, all the different contents. That's what we're talking about when we say we're using shared infrastructures. These kind of risks are out there. I don't know if any of you had heard of these systems when using these resources, but this is one of the things that we consider. You don't need any kind of exaggerated knowledge to access these things. So let's just look. Because we were in a hurry, we've brought with us the machine that we're developing in our app that we're forever modifying. And also because we've got a lot of data in it, so we didn't want to share all of the data. Let's start it. And I'll leave it in your hands. This tool that we've developed, and which is what it's going to allow us to do, is to group together a series of auditing tools, perhaps simply. It's going to be available in the GitHub, as like all presentations that we have been given here. No, the password isn't 1234. You can choose a tool from here. Just trying to connect. It's a collection of tools, not all of the ones that we use all the time, but it's just for the demo today. We also wanted to show you the ones that are developed by Netflix. I like Chaos Monkey because it makes my colleagues in production go mad. What it does is it makes different operations go somewhat mad, and it turns the machines off just in a random fashion. It's to create chaos. It's quite obvious. Chaos Monkey. Imagine it's a monkey going around turning things on. But we're going to talk here about Prowler. Prowler is a tool. We're going to use it with Amazon in this case. And what it's going to do is give us information about the compliance and basic security of our accounts. It's got the default passwords, whether we've left any ports open, etc. This tool lets us check users. users that have kept the same password for more than 90 days. It'll give us some basic advice. Some will depend upon the kind of infrastructure that we've deployed. And what I like about this tool is that it's multi-tenant, and we can set it up with different instances and different AWS accounts at the same time. Of course, we'll gradually see the warnings, the reminders that we get. And if there's a serious violation, it won't tell us. So we'll see default passwords, ports that we're using, and any malpractice. And here, in this specific case, it's showing us several faults. For example, you haven't generated encrypted passwords. Some metrics are giving you strange values. This also allows us to give our own rules and codes. But we need to be aware that we have these tools. What's important is that we spend part of our time, our infrastructure time, to create and maintain a state of the art where all these tools are reflected and documented and updated, checked, and try to use them as much as possible and automate them. How can they be automated? Well, this is part of the audits that we have to carry out, and both all the risks that we've looked at and all the things that are out there. We realized via a friend the other day that the new VGPD are going to force all public institutions to have 2 audits per year. And that's going to be very interesting because people are reluctant to do so. They will say, okay, why me? Why me? You're going to make me do that? Yes. It's as simple as that. And I've seen it firsthand. From a security viewpoint, by the way, this is a little bit obsolete now, that you need to remember that. It's just obligatory, and it's going to be securer for everybody. It's going to be safer for everybody if people are forced to do an audit twice a year. I was just having a look at it because despite the fact that this is a trial account for this demo, you can see that with a default setup, all kinds of different problems that need to be taken into account are being thrown up. So we have to look at it first, and we can see that these tools can have lots of accessibility. When I say lots of it, you're going to find a bit more and more. You need to see that the information that you get is reliable and updated. Otherwise, as you can probably imagine, the cloud world is an ever-changing world. And a tool from 4 years ago isn't useful because it's not going to take into account many of the things that exist today. And it's not just this what we need when we use cloud, because there's here a series of things that actually won't happen. You'd also need the possibility of carrying out pen tests and try to monitor them. And many of the providers that you're going to have will refuse to do this. They won't want to do this. We're also saying that these kind of tools there's one out there called Kitploit, which talks about many tools. It's got this own tool which standardizes many pet test tools. We've got a small spin-off as well, and each cloud platform is its own little world. If we have VMware or Azure, it's mostly all the same, but if we tend more to a type of open nebula infrastructure, open stack, things are a lot different, especially in OpenStack, where you have one machine for each essential service of our cloud, one which is for users, another which moves a messaging service between the different machines, another which is just for the net, which is neutrino, another which is just for storage to bring together all the different components or infrastructure disks that we have and make that this literally works. And how can you audit all of that? You have to start with the basics. You're always going to need to have some kind of a matrix where actually from a legal viewpoint, you're going to have to meet all the necessary requirements. In addition to that, you're going to need on that matrix to gradually incorporate more and more technical advice. Why? Because it changes very rapidly, as Antonio says. In Open Nebula, which is used a lot, I don't know if you know Open Nebula, it's a cloud system set up by several providers. All the major manufacturers have joined it. And in fact, governments have taken part in it. And overnight, I think it was on version 8, they changed all the management part. Everybody that was certified and used to using this system, this change has just destroyed them. You found all these different badly set up panels, something that's very important just in a simple search. Because of this, this always takes us to the same conclusion, which is that training is very important. Now, this issue of ports, and we're seeing that now. You can see which are open. An interesting point of this auditing system is not that it's just what I'm seeing, but that it produces a report that can be used, because there's some of these kind of audits in which the reports that it produces aren't very good. Within these pen tests, let's look at the most basic pen test. The most basic, of course, is always going to be Nmap. Then, depending upon the type of infrastructure, there's some that try to look at the faults that I have. What about open source pen test? There's WhatStart. You can use Nexus, Open Bus, depending on the kind of pen test you want to carry out. And if I want to carry out an audit before contracting somebody, just for the basics, what is the most important part of these audits? Or what's the most important part of these tools? Well, you have to tool around, because any tool that you have, the worst thing that could happen is that you use too many resources, that you destroy the information. That's simply so. The first thing is to guarantee that our tool isn't intrusive. If I want something that's intrusive, then I need to be clear on that, but it's not something that anybody can do. Does this never end? I think it's got more information here than you need. You've left the port open. It's a broad audit, a thorough one. Maybe we've loaded too many machines. But whilst this carries on, if the colleague that helped us design this thinks that we've done something bad, can you please send us a WhatsApp? And in these kinds of audits, it's important the technology that we use, the providers, what tools we have, what budget, and also training. These kind of events, a CyberCamp event where you've got these kind of workshops where we can see how complex it is to cover everybody's expectations, to meet everybody's expectations, are still very important because they provide us a lot of information, useful information. That's true. So Coming back to the issue of risks, this is something that I'd left to one side. Awareness, training, and compliance is really important for all these sort of things. I think we should stop it now because it's just duplicating. We've done something wrong. Either we put too many accounts in there, or we've asked it to look at too many machines. Let's talk about the others. Let's have a look at another machine that's a bit more prepared. This is another one that we're trialing at lunchtime, where we've included a series of additional tools within the menu, and we're going to upload this to GitHub, and we'll explain how more tools can be added. It's made to measure. We're going to have one version for free that everybody will use, and that'll simplify our uses. Moving back to pen test tools. Sometimes give you they give you very complex reports. WhatsApp is one of the most recommended one. If you're using it, it updates. It's quite frequent, the updates, and it can be a good starting point. But we need to consider that one of the most complicated things that you find are false positives. We like these kinds of tools, and the one that we use internally is a little bit more advanced. It's got some additional options because we work from the attack tree perspective. We try to see what sort of infrastructure the customer has, and with that define the attack plan and just use a logical port, mark the order in what we're going to audit, and see what information we get. In this case, it's always going to ask for the same thing, and we can choose the ones that we want to run and then wait. It is very important to define the scope. No, it seems we can't connect. That's what happens when you're doing things live. It's very important to define the scope of an audit. Because recently, the other day, I was designing a sort of a home system using Overget to make backup systems. And I was looking at Overget and seeing what I had, and I didn't realize that machine that I was sending the resources from had more than the one that was receiving it. This is quite common with open test trials. We may see that we've got more resources than the customer, and we may create problems. So scope is very important when you do this on pre-production environments rather than production environments. These are perhaps a couple of the best pieces of advice that we can give you. This is another thing that you need to consider. Of course, it depends on the type of clouds that you've got, but you can't put it in anybody's hands. That's a terrible problem when you talk about data, but not just when you talk about data. Remember that one of the things that we could provoke is excess information. It's not just so much data traffic, but I might actually start creating dirty data and ruin somebody. Especially when automating a connection test in a database. It's really unforeseeable when you talk about typical pen test tools. Just be careful, because otherwise you might ruin something, not just the expense account, but it may well be we don't want corrupt information. That's also very important. If you've got any questions while we're trying to get this to work, please do ask them. Something we're doing wrong because we can't get the final report. If you've got any further questions while we're trying to make this run, please interrupt. For some reason, it's not giving us the final report. Okay, at the end, when it finishes, it will create a report, and where we'll be able to see all the reminders and warnings and any problems that we may have had. If it doesn't finish today, it doesn't matter. We'll still let you use the tool with a free account.
Any questions before we get to the next part? If you have no questions, we'll try to finish. We have still 20 minutes to go. We'll talk about infrastructures, and then we'll be over. No questions. My name is Pedro. National providers. We've seen the big ones. And if you have to abide by the data protection rules or national security legislation, do you know any Spanish suppliers giving guarantees? We cannot mention any of those. I cannot make any advertising. There are cloud and local cloud suppliers in Spain. They specify where the data center is. One that I won't mention here has a data center in China and in Spain, and you can choose if you want to hire those services in China or in Spain. After the talk, we can mention 3 or 4 suppliers. I don't want to be in conflict because some of the providers are friends, others are not friends of mine, so I can help you later with the names. In theory, any provider having their installations here in Spain have to abide by the Spanish legislation, not just the legislation. You need to know that we have always to audit providers. You can't ask simple questions. Are you going to separate the data route? Do you have 24 hours personnel? Is it yours? Is it third parties? Who can access servers? If other customers can get in, do I share my infrastructures with many customers? If this burns down, what happens? There is an SPD authoring questions nobody can answer. The Prosegur guy there on the 4th row can cover that because they offer simple products. If there is a bomb falling on the data center, if there's a ruin with a big crater, what happens if the bomb falls here? How do you solve this problem? Well, the vast majority of data centers have a special service called human code. There are security guards. They're not even going to look the crater, but they're going to place themselves around the crater so that nobody can see and get there. This is good for business continuity. If this data have been destroyed forever, secondly, how much do we have to pay for that? Do you have replicated the data some other place? In Madrid, you can have the data center here, but you can connect to other servers with fiber. If a data center crashes, you need to have another center. All data centers in Madrid have suffered zero, the absolute zero. This happens all over the place. But if this happened with the cloud virtualization technology, all infrastructures will restart in other data centers. We're not going to lose work. We're not going to stop for a long time. But it's important to know if that backup server is still in the same city, in Spain or in China. Those audits are very important when your project is big and important, or when it's very relevant. The provider is going to answer that question. You're going to have a meeting, you will see the data center, you will have explanations about the generators, the gas, the fuel is in another building. They're going to give you all the technical details of how a data server works, if it's a good provider. And they should give you the explanations, and they normally have standards and certifications, ISO standards. If I want to hire a service of this type in Spain, first of all, I'd like to go to see the provider's data center. He can show it to you. There are areas in CPDs that we can consider as critical. You can't get in, of course. You will have answers about the features. You will know where bank data are managed, but you can't get in. But you have to be sure that they have certifications. My advice is that, well, when I make audits, I want to see the things. I want to see the facilities. Don't tell me what are your certifications. I want evidence of that, because I'm the person responsible for everything happening later. And if they can't offer you that, you can change. And you don't, or maybe it's not necessary for you, but you can choose. Any questions?
Pues en vista de que los fallos del directo no se...
So we couldn't see the report. It would be quite interesting to see it. And we are late for lunch. I think we can stop it now. We can stop now if we want to. Any questions? Great, thank you.